Okay, so what is the question? 2 raised to 60 divided by 5, and you need to see the remainder, right? So this is 2 raised to n number, and we know the method of finding the remainder if you get in this format, right? So what we'll do, we will write this 2 raised to n number in such a way that when you divide with the denominator, leaves a +1 or a -1 remainder, right? You will write it as 2 raised to 2, okay? So you know 2 raised to 2 is 4, and 4 divided by 5, what is the remainder? 4. Or you can also write it as -1, right? So if I write it like 2 raised to 2, I can get -1 as a remainder. So 2 raised to 2 divided by 5 will give me -1 remainder. So I can get how many such 2 raised to 2's? Here I have 60, so I need to write it as 2 raised to 2 raised to 30, right? So into 2 raised to 2 by 5 into 2 raised to 2 by 5, like that 30 times, right? So how will you write the answer? You know the remainder here, -1. And 30 times -1 raised to 30. -1 and even number, you write it as 1. So answer for this question is 1, right? Now here if you see 55n divided by 124, and there is no remainder. That's what they are saying, right? So what is the minimum integral value of n, right? So now here if you observe these two numbers 55 and 124, there is no common factor. These are in fact co-prime numbers, right? So no common factors between 55 and 124. So 55n, if need to be divided by 124, n should be a multiple of 124, okay? And we are asked to find the least number, right? So minimum integral value of n, right? So it has to be 124 itself. So what we did is there is no common factor between them. So n has to be multiple of 124. Then only 55n is divisible by 124. So n can be like anything. N can be 124, 248, etc., etc. It will go, right? N can be any multiple of 124. It will be completely divisible by 124 and leaves no remainder. But what is asked is minimum integral value of n, right? That is nothing but 124 itself, right? So what is the answer for this question? It is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? How many digits are there? 180 digits are there, right? Divide by 11. What is the remainder, right? What is the answer here? See, here what you can do is you can group it into a group of 9 itself, right? Because what is the divisibility rule of 11? You can, I told you for 11 you have enough flexibility. You can either group it into a group of 1. That is what you generally do. But if you group it into a group of 1, it is slightly difficult. Or you can group it into 3 or 5 or 7 or 9. If you do it in terms of 9, if you can group it like this is one group, this is another group, such kind of 20 groups are there, 10 positive group and 10 negative groups, so you'll get the answer directly, right? So in this question, it is 5 raised to 6 minus 1 is divisible by which of the following, right? So how can you do is, you will write 5 raised to 6 as 5 cube raised to 2 minus 1, right? Now there is nothing but 125 square minus 1 square. You will write it in this way. So this is in this format, a plus b into a minus b. So you'll write it as 125 plus 1 and 125 minus 1, right? What does this mean? This number 125 square minus 1 square, or this number is divisible by 125 plus 1 and 125 minus 1. That is 126 and 124, right? So what does this mean actually? 126 is a factor of this, and 124 is also a factor of it. Or what you can say, 5 raised to 6 minus 1 is divisible by 126 as well as 124. Now if it is divisible by 126, all the factors of 126 also can divide 5 raised to 6 minus 1. Same way, if 124 can be used to divide 5 raised to 6 minus 1 without any remainder, means all the factors of 124 can also use to divide 5 raised to 6 minus 1. So in this case, 31 is one of the factor of 124, because 31 into 4 is actually 124. Right? So with 4 also you can divide, with 31 also you can divide. So which one you'll pick? You'll pick 31 as your answer. Now what they're asking in this question, what is the smallest number which when increased by 5 completely divisible by 8, 11 and 24, right? Now this is your type 2, right, where the difference between divisor and the remainder is same. How will you write this? This is nothing but you increase by 5 is completely divisible. What does this mean? When you divide by 8, what is the present remainder? 3. That's when you increase by 5 it is completely divisible, right? That is the difference. Now this is 11 means what is the remainder? Remainder is 6. That's when you increase by 5 completely divisible, right? Now when you divide by 24, what is the remainder? Remainder is nothing but 19. That's when you increase by 5 leaves the remainder 0. That means completely divisible, right? So if you want, you can write in this way. The number is nothing but 8a plus 3, which is also equal to 11b plus 6, which is also equal to 24c plus 19. Right? What does this mean? The present remainder is 3, but if you increase by 5, okay, increase by 5 leaves the remainder 0. That means it is completely divisible by 8. Now in the second case, the present remainder is 6. If you increase by 5, it is completely divisible. Now the present remainder in the third case is 19. When you increase by 5, it is completely divisible. But they are not saying that what is the remainder, 3, 6 and 19. Rather, they are making it more easier by saying that the difference between the divisor and remainder is 5. Because we have learned in that way only. We have discussed in that way only. The type 2's difference between divisor and remainder is same. Otherwise, if they are giving in this way, we need to find the difference. We need to check whether the difference is same or not. Here they are directly saying in all the 3 cases, difference between the divisor and remainder is same, right? So what is your answer? In this case, your answer is LCM minus the difference. So the question is remainder obtained when a prime number greater than 6 is divided by 6, right? So what you need to do is just take any prime number greater than 6, let's take 7, divide by 6, see what is the remainder, you get 1 as a remainder, right? Now you look into options, your options A and B says 1, right? A says 1 or 3 and B says 1 or 5. So it can be A or B, okay? So what you need to do is take the next number, next prime number 11 by 6, what is the remainder? 5. Now you can pick B as the answer, 1 or 5. Okay, how will you solve this question? 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., 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 39, 40, right? So divided by 9, what is the remainder, right? So here you need to check the divisibility rule of 9. So this is something which we have already discussed. Divisibility rule of 9 is sum of digits. You can either take sum of digits or you take sum of digits till you get a single digit. And if you get a final digit which is a single digit, that will be the remainder when you divide the number by 9, right? Now how will you find sum of digits here? What you can do is up to 9, what you can do is take one digit at a time, and after 9 from 10 onwards up to 40 you can take 2 digits at a time, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9 you can take sum. So sigma 9 you can find. Then basically from 10 to 40 also you can find the sum only, right? So this question you can basically convert into sigma n question or sigma 40 question, right? You need to find sigma 40. Why? Because up to 9 you are taking one digit at a time, and after 9, that means 10 to 40 you are taking two digits at a time. Now find the sum, okay, of first 40 natural numbers. That is nothing but sigma 40. You know this is 40 into 41 divided by 2, right? And you get it as 820. So this bigger number, if you divide by 9, you get a remainder. Okay, the same remainder you will get if you divide 820 by 9 also. Now 820 divided by 9, what is the remainder? You don't want to divide it, you can still find sum of digits. Sum of digits is 10, 8 plus 2, 10. Still you can find sum of digits, 1 plus 0, 1, right? So answer for this question is 1. That means if you divide this bigger number by 9 and if you divide 820 by 9, in both cases you'll get 1 as a remainder. That is a divisibility rule of 1. Sum of digits, still you get a single digit. Or here also you can get that, okay? So divide this, you get 20. So basically this is nothing but 20 into 41, right? You can take sum of digits here also, because now sigma n is nothing but, from here you can write sigma n as 20 into 41, right? This is what sigma n, that is what 820. Now rather than doing this step, you can see the remainder divided by 9 here also, right? Now these are factorized, right? Numerator is factorized, and you know the basic remainder theorem. Based on basic remainder theorem, you find the individual reminders. How will you find the individual reminders? You just take the sum of digits of this, right? That is nothing but 2. You take the sum of digits of this, that is nothing but 5. Now if you multiply 2 into 5, you get 10. 10 means 1 is a remainder. Again you take sum of digits, 1 is a remainder, right? So in any way you'll get sum of digits. If you take till single digit, you get 1 as the answer. That is what the remainder when the bigger number is divided by 9, right? So what you have done is nothing but you found sigma 40. Why sigma 40? You converted that question to sigma 40 question. Why? Because you are taking up to 9 one digit at a time, and after 9 from 10 to 40 two digits at a time, taking sum, right? So this is nothing but 40 into 41 by 2. Okay, so this is nothing but, if you divide 20, this is nothing but 20 into 41. So you got a number, sum of digits, sum as 20 into 41, right? What we need to see is, again you need to divide by 9. So how to find divided by 9 remainder? You take sum of digits only. So 20 divided by 9 means you take sum of digits 2. 41 divided by 9 means again you take sum of digits, you get 5. Now this is nothing but you are applying basic remainder theorem. So the actual remainder will be product of individual reminders. So this will give you 10. 10 means again take sum of digits, you can get 1. 10 means you need to divide again by 9, right? Which is because the product of individual remainder, if you find, if it is greater than the divisor is 9 here, if it is greater than the divisor, you need to divide by 9 again, so you are getting 1. Or this is nothing but 820. You need to divide 820 by 9, nothing but sum of digits, right? 10, which is equal to 1. Anyway you can do this. What you need to do in this question, the concepts and all we have already discussed, right? So here what they're saying is a number which when divided by 899, you get a remainder 63, right? Now what will be the remainder when the same number is divided by 29, right? Now you know this, the method and everything that we have already discussed. There is no method as such, only concept is, if a number is divisible by, let's say, a, all the factors of a will also divide the same number, right? But here it is not divisible. What they're saying is a number which when divided by 899 leaves a remainder 63. Now if you look into 29, 29 is a factor of 899, right? That means you take this remainder, you divide by 29, you will get the answer. 5 is the answer, right? Because 29 is a factor of 899. So if 899 divide the number and leaves remainder 63, means answer for division with 29 will also depends on the remainder which you got in case of 899, right? So 63 is what you got. Divide 63 further with 29. You get the answer. Answer for this question is A, right? Now in this question what you need to do, what they are saying is number A is a set of positive integers such that when divided by 2, 3, 4, 5, 6 leaves remainders 1, 2, 3, 4, 5 respectively, right? So what are the divisors? 2, 3, 4, 5, 6. You get reminders 1, 2, 3, 4, 5 respectively. So how will you write it? What is n? N, if you want to write, n is equal to, when you divide by 2 leaves a remainder 1, when you divide by 3 leaves a remainder 2, when you divide by 4 leaves a remainder 3, when you divide by 5, right, leaves a remainder 4, when you divide by 6 leaves a remainder 5. Okay, so when you divide by 2 leaves a remainder 1, divide by 3 leaves a remainder 2, divide by 4 leaves a remainder 3, divide by 5 leaves a remainder 4, divide by 6 leaves a remainder 5. What does this mean? If you take this difference 1, this difference 1, this difference 1, this difference 1, this difference 1. So if you see in all these cases, the difference between the divisor and the remainder, if you take it, is constant 1. So this belongs to my type 2 that we have discussed, where the difference between the divisor and the remainder is same, just like the previous question. What is your answer? LCM of all the divisors, here it is 2, 3, 4, 5, 6, right? Minus, what is the difference between the divisor and remainder, right? The constant difference, that is nothing but 1. So if you take LCM, what you will get? 60. LCM of 2, 3, 4, 5, 6 is 60. Your answer is 60 minus 1, that is 59. No, not the answer. The first possible number is 59. Now how many such possible numbers are there in a range of 100 is what they are asking, right? What is the next possible number? How to get it? 59 plus, again LCM of divisors, right? LCM of divisors is 60. So 119 is the next possible number, which is greater than 100. So how many numbers are there within a range of 100? Only 59 numbers are there. So you understood that 59 is the first number, 60 is the common difference. You are going to get an AP with a common difference of 60. So there are many numbers which satisfy this condition. 59 is the least one. What they are asked is, within 100 how many is there? Only 1 is there, because the next is 119. Okay, now if they want, they can frame different questions also from this. A number which when divided by 2, 3, 4, 5, 6 leaves remainder 1, 2, 3, 4, 5 respectively. What will be the remainder if the same number is divided by, let's say, 30? You're just saying 30. Can you find the answer? You understood the first term is 59, second term is 59 plus 60, right? And third term is 60, 60, 60. You keep on adding with that, right? So my question is, you take any term from this, you don't know what is the value of n. N can be anything which satisfy the condition, divide by 2, 3, 4, 5, 6, leaves remainder 1, 2, 3, 4, 5. N can be any number in the series which satisfy the condition, right? I don't know what is the value of n. If I know the value of n, I take the value of n, I divide by 30. But here I don't know the value of n. But they are asking you what will be the remainder when the same number divided by 30. We don't know what is that number. But what we'll do, we understood that this is an AP, right? So if it is an AP, what is constant remainder theorem? Any term in the AP, if you take divide with the common difference, here what is the common difference? 60. Same will be the remainder in all cases, right? So to find the 100th term divided by 60, what is the remainder? I can just find what is the first term, 59 by 60, what is the remainder? 59 itself. So 100th term divided by 60 also will give you 69. 1000th term divided by 60 also will give you 59. Any term if you take for that matter will give you the remainder 59 if you divide by 60. And not only by 60, any factors of 60 will also give you the same remainder. So based on that only they ask the question here, divided by 30. So you divide any term in the AP with the factors of the common difference will give you the same remainder. 1000 term or 100 term or what a first term. So you take first term 59 by 30, what is your answer? 29. So 29 will be the remainder if you divide 100 term or 30th term or 40th term or 1000 term with 30. So if you know the first term, if you know the common difference, you can find this. But what if they ask you what will be the remainder if 13 divide the same number? Then your answer cannot be determined because 13 is not a factor. And if you try with the first term 59, you get one remainder, 7. If you try with the second term, you get another remainder, third term another remainder. So you cannot determine the answer, right? So if the question is based on the common difference or the factors of common difference, you can get the answer. If it is based on any other random number, cannot be determined as your answer. So the question is solved for any question. Because two possibilities, either you will get a question on the basis of common difference or the factors of common difference or any random number. If it is common difference or factors of common difference, you can get the answer. From the first term itself, you can get the answer. Because first term divided by common difference or factors of common difference, what is the remainder will be the same in case of all the numbers. Now if it is not factors of the common difference, you cannot determine the answer. Simple. So what is this? 2 raised to 51, you need to find the last digit, right? So how will you do it? We have discussed about power cycle, frequency and everything. What is the frequency of 2? It is 4, right? So you just take out the power, 51, divide by 4, see what is the remainder, 3, you will write it as 2 cube, which is equal to 8, and you will mark answer as B, right? What we did, we used power cycle, right? And what is the power cycle of 2? 2 raised to 1 is 2, 2 square is 4, 2 cube is 8, 2 raised to 4 is 6, right? 16. So these are the possibility. You don't want to remember anything. Any number if you get, right, let's take 2 raised to 84. You need to find the last digit. You need to convert this 2 raised to 84 into one of this number, right? So how will you do that? 84 divided by 4. You get 0 remainder, right? If it is 0 remainder means 2 raised to 4. If it was 85, remainder is 1. So it is 2 raised to 1. If it was 86, remainder is 2. Then it is 2 raised to 2. Last digit will be 2. Last digit will be 4. If it was 87, remainder will be 3, you will pick this. If it is 88, 2 raised to 88, remainder will be 0, so you will take 2 raised to 4. So these are the 4 possibilities. Okay, what you will do in this question, how many 6-digit numbers starting with 523 is divisible by 789, right? So starting with 523 is divisible by 789. It's just a random question, so question like this will make it difficult generally. See, what you need to do, what is the LCM of 789? It is nothing but 504, right? So how many numbers will be there is basically, you can divide 1000 by 504, right? You know it is either 1 or 2. Now in this question you can answer, because your options, if you see, there is no 1 which is given. You know there are only 2 possible numbers. See, if the first term is given, which is divisible by 789, you can find it easily, right? Because second term will be, you are adding 504 plus the first term, but the problem here is you don't know the first term. To find first term it is difficult. You need to try the divisibility of 8 and 9. 7 will be little tough. You can try the divisibility of 8 and 9, that is last 3 digits must be divisible by 8. You need to see those numbers which is divisible by 8, and sum of digits should be divisible by 9. So this two you can try, and you need to try a lot, right? So finding the first digit will be difficult here. First number will be difficult here. That's why this question is difficult. If the options are like 1, 2, 3, 4, then this is going to be a round 2 question. You don't attempt it in round 1. But here, since your options, you don't have 1, you know it's either 1 or 2. You can mark 2 as the answer. Then it is round 1 question. Here, you can mark it faster because you understood LCM is 504, right? So there will be a gap of 504 with the 2 such numbers, right? With 2 such numbers, there will be a gap of 504. That is basically, if you get the first number, second number will be what? First plus 504. And then it is going to make an AP with 504 common difference. So this is nothing but they are asking you within a range of 1000, how many such possible terms are there with a common difference 504, right? So you just need to divide, and you know it is either 1 or 2. If the starting number is 523101, then you can just add 504, you can get the second number. Then there is no third number possible, right? So these are the 2 possibilities. There is the first one, there is the second one. But the problem is you don't know the first one. So what you can only tell here is it's either 1 or 2. Now here, since 1 option is not there, 2 is your answer. Or basically if they are asking you how many such numbers are there with a common difference of 99, what you will do? You divide 1000 by 99. You know it's either 10 or 11. So if both are there in your option, it is difficult because you need to find the first term. If any one of this is only there in option, if only 10 is there, 11 is not there, you can pick it. You don't want to find the first term. Okay, because if you find the first term, then it is going to make an AP with a common difference of 99. Everything will be like 99k. This is a series, right? Or here also it was first term. If you can find out, next will be 504k. Then it is a series. Next will be 504 plus 504. It will go on, right? So basically, what you need to do is, how many possibilities are there? 1 or 2. Because if up to, if it is let's suppose 523 495, up to 495, if it was any value, the last 3 digits up to, if it is up to 495, the next will be, you add 504, so this will be 9. So how many is possible? This is 1, this is 1. If it is 494, this will be 8. So again 2 is possible. Okay, so if it was if the first number is between 523001 and 523495, if the first number is between these two, you have 2 such possible numbers starting with 523. If the first number is greater than 495, let's take 523496, then the second number will be 504, right? So this is 0, this is 0, again this is 0, 4, 2, 5, starting with 524. So you have only one answer. That is a problem. So you need to understand whether the first number is less than 523495. If it is less than 495, you have 2 answers. If it is greater than this, you have only one answer. But to find whether it is less than this or not is a matter of time. That's why it is a round 2 question. If your options are 1, 2, 3, 4, but here you can directly pick it as 2 because it's either 1 or 2. How? 1000 divided by 504, you have only 2 possibilities. If it was 99, 1000 divided by 99, it's either 10 or 11. So if both are there in your option, you need to find the first term and the last term. Then you need to find the number of terms. Here, if it is only 1 is there in the option, you will mark 1 as answer, 11 as answer, or 10 as answer, based on that. Now this question depends on the divisibility rule of 8, right? So you have a number which is given. That number is found by writing the first 54 natural numbers, right? 1, 2, 3, 4, etc, 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 53, 54, right? So this is the number which is given. Divide by 8, you need to see the remainder. So what is the divisibility rule of 8 that we have discussed? Last 3 digits, right? So the remainder also depends on the last 3 digits, right? So here last 3 digit is 354. Now when you divide 354 by 8, you get remainder as 2. What does this mean? When you divide the bigger number with 8, then also you'll get the remainder as 2, right? So there is no point in dividing the bigger number with 8. If you need to divide it with 8 and see the remainder, you can divide the last 3 digits with 8 and see the remainder. Both will be same. See, the point is what I said, what I told you is, this bigger number divided by 8, what is the remainder? 2. Or if the small number divided by 8, what is the remainder? 2. Both will be same, right? So rather than dividing the bigger number by 8, which is impossible in this case, we can divide this last 3 digits with 8 and see the remainder. It will be same as that of the bigger number divided by 8, right? So what if the question was divided by 4, what is the remainder? Instead of 8, divide by 4, what is the remainder? Then the divisibility of 4 depends on last 2 digits, right? So 54, divide by 4 you will do. Rather than dividing 1, 2, 3, 4 up to 54, so you will just take the last 2 digits and divide by 4, and what is the answer? 2 is the answer. So what does this mean? 54 divided by 4, your answer is 2. That will be same as that of this bigger number divided by 4. Remainder.